This video presents a proposed split regulation of robocalling. 4 topics will be discussed. Why is this approach used? The simplicity of implementation, demonstrating the actual running of code, and a summary of the advantages. The problem with regulating robocalls is the multiple agents involved. There are sources that provide the material and callers that do the actual connections. Who then takes responsibility for content? The solution is a split liability. The sources are responsible for the content itself and the calling groups for the delivery. Execution follows 3 steps. Both groups must register, then they must provide whatever they are responsible for ahead of time, and they are monitored to ensure that what they are providing is proper. The approach might require some legislation, but it's worth it. The goal here is divide and conquer. Each of 3 precise types of illegal activities can be pinpointed and targeted. Any unscheduled robocaller can be shut down. Illegal content is the liability of the source, and switched messages has been perpetrated by the calling groups. The whole enforcement is complaint-oriented. You might say that without any complaints, it's a victimless crime. Investigation for each of the 3 types of offenders follows complaints, and ultimately blocking of outgoing calls. The implementation is fundamentally in a database with a user interface and telephony, but the simplicity of the solution stems from the fact that fundamentally it's a very simple database. All of the queries as well as the schema are brought in the implementation section of the proposal. The front-end interface is trivial to create, and telephony on top of that is also very simple. The emulator you're about to see uses the precise queries that are brought in the 3rd section of the proposal, with 250 lines of highly redundant code and 3 simple forms. This emulator simulates customer actions on the left, including complaining about a robocall or dialing a scheduled call and dialing an unscheduled call. On the right is recorded the results. Let's start with an unscheduled call. Our origin and destination are specified, and then we dial the number. The connection is made. A user can complain, but as long as there's no history of complaints, it won't affect the sender. Now let's do another call, but this time from somebody with a history of complaints against them. Once the complaint is registered, you can see that a maximum has been exceeded and the next call will be tested. So let's send another connection request from that number, and you can see that they are tested. Let's fail them, and they lose their service. As far as a scheduled request goes, the code has to be specified. And this time, the origin is from the calling group, and the source is from the list of numbers to call. A discrepancy test is done randomly, and if it's failed, then the calling group can be frozen if they've been failed before. But if a source has received a number of complaints, then even though the calling group is not in trouble, the person who complains about the call, they might be told that the call is within legal boundaries in terms of scheduling, but nevertheless they can complain about the content of the call, in which case the source must be audited, and if the source fails, then the source gets frozen. The advantages of this approach include a tremendous simplicity to the user, no change of service, no hardware required, and no hardware required for the networks. It also can be implemented very quickly and gradually, starting from just one network. And above all, it's highly flexible and allows for a robust protection from robocalling no matter what form it takes.